right, so we're going to talk about the fundamental theorem of calculus and particle motion along with average value. And we've got three things to always keep in mind. Okay, the first one is the definite integral from a to b of vt dt. So that would be v would be your velocity. So you're going to go back one from velocity. So that's going to be position, right? So that would be P of B minus P of A, where V of T represents the velocity and P of T represents the position. Okay. The second thing to keep in mind, from A to B, the velocity, let me straighten this paper. Here you go. The velocity, V of T dt, is the net distance the particle travels. If you're going back up to position, then you just talked about the net distance. If my position was here and now it's here, then that's a net distance that I just traveled. Okay. So from the interval of t equals a to t equals b, if v of t is greater than 0 on the interval from a to b, then it also represents the total distance. Now, if you need total distance, like you need it and you're not sure if it was always greater than 0, you don't know if it went back and forth, then we need the absolute value for the total distance the particle travels. And here's a good hint to be safe. Always do this integral when asked to find total distance when given velocity. Always. So, like, think about this. If you have some graph and it goes like this, and this is V of t, and you're going from A to B. So you're looking at this area right here. That's what you're looking at, right? Now, if it, let me see if I can draw that exact thing again. Probably not, but we'll pretend that I did. Okay, so let's say this is A and this is B. So what happened? Part of it went under. So what we have to do is we have to go, okay, well, actually, I'm doing this from here, and then I'm going to come up, and I'm looking at this part right here. And that would be the absolute value of V of t. So you can get your total distance there, okay? All right, so let's do this first problem here. So we've got the velocity of a particle. Hang on. Wrong way. I feel so afflicted. I feel so much like a boomer right now, which I don't know what to do with my hands. Okay. The velocity of a particle that's moving along the x-axis is given by this function right here. V of t equals 3t squared plus 6. This is a non-calculator question. What the heck? Okay. If the position of the particle at t equals 4 is 72, what's the position when t equals 2? Okay, so we're going from 2 to 4. Okay, so we're going from 2 to 4, v of t dt. So that would equal p of 4 minus p of 2, right? So on this side, like, we have an equation right here. See, I circled it. V of t equals 3t squared plus 6. So we have an equation. So on this side, we're going to take that definite integral. We're going to say, okay, so that's going to be from 2 to 4 of 3t squared plus 6 dt equals p of 4 minus p of 2. Or t cubed plus 6t from 2 to 4 is equal to 72 minus p of 2. So at this point, I can plug in things and I can figure out everything and have p of 2 left by itself. So that's going to be, don't tell anyone I coughed. That's going to be 4 cubed plus 6 times 4 minus 2 cubed plus 6 times 2 equals 72 minus p of 2. All right, so that's going to be 88 minus 8 plus 12 minus 20. I'm running out of room, so I'm going to go ahead and move that minus 72 over here. Okay, so that's going to be negative 92. So I've got a negative 4 equals a negative p of 2, or p of 2 equals 4. All right, what's the total distance the particle travels on the interval from t equals 0 to t equals 7? All right, total distance. From 0 to 7, this is all above the x-axis. Don't tell anyone I sneezed. Okay. So that's just going to be from 0 to 7 of 3t squared plus 6 dt. So that's going to be, we already did this, t cubed plus 6t from 0 to 7. 7 cubed plus 6 times 7. Is it weird that I remember 7 cubed more than I remember 6 times 7? This is 343, and I have to think about that one. Anyway. And then these are all just going to zero out, minus 0. Okay, so that's 343 plus 42, which is 385. All right. Okay. I'm going to turn it over. If you need more time, just pause the video. Okay. Everyone's messaging me what time they want to meet. That's why my phone keeps going off. Okay, the velocity of a particle is moving along the x-axis, and let's see, we've got this function v of t equals 0.5 e to the t times t minus 2 cubed. Whew, e, oh, that's not pretty. All right, this is a calculator active question. Yes, it is. Generally, if there's an e involved, you're going to be able to use your calculator because you have to type e in. You can't, like, no one expects you to have that memorized and be able to take it to a power or anything like that. Okay, so if the position of the particle t equals 1.5 is 2.551, what's the position? So we're going to do the same thing that we just did, okay? So we're finding the definite integral from 1.5 to 3.5, 0.5 e to the t minus 2 to the third, dt equals the position at 3.5 minus the position at 1.5. Now, this can go in your calculator, okay? And I'm not going to take a lot of time to show you how to do it right now because you're at home, you've got internet, but you can do an integral on your calculator, okay? And so you just, and it looks just like what we've been doing, okay? So you can put that into your calculator, 1.5, 3.5, and then you put in the function e to the what? T, so I have to use x though, times x minus 2 to the third dx. And I get 15.919 equals, and then which one do I have? P of 1.5. Okay, so I don't know P of 3.5, but I know P of 1.5 is 2.551. So that just means that P of 3.5 is equal to 15.919 plus 2.551, which is 18.470 right there. Total distance. Total distance on this one is a little bit different. On this one, I think that it goes above and below. But again, it's calculator active. So I'm going to go from 1 to 5 of the absolute value of 0.5 e. Let me put a 0 so it doesn't look like 1 to the t times t minus 2 cubed dt. Absolute value bars. Absolute value bars. Okay. So I'm going to put that in my calculator. From 1 to 5. And then absolute value. So see, I've got, I don't know if you can see that, but I've got absolute value bars in there. Okay. And then 0.5 e to the t, and then t minus 2 to the third dt. But I'm not actually using t. If you want to take the time to hit alpha and t, then go for it. But, you know, it's a time test, right? So there you go. Takes my calculator. Oh, there we go. Just put that in there. 913.067. Remember, if on the AP exam, if you have a calculator, they expect you to use a calculator. So they're not giving you a lot of extra time to do things. So you need to do things as quickly as you can using your calculator. All right, so now we have the graph of the velocity measured in feet per second of a particle moving along the x-axis is pictured below. So this is velocity. The position P of t is 8. T at t equals 8 is 12. So what that means is P of 8 equals 12. By the way, this is feet per second. I feel like if they told us that, then we're going to have to put units on here somewhere. Use the graph and answer the questions that follow. What is the position of the particle at t equals 3? Okay, so we're going to use from 3 to 8. Why are we using 8? Because I know 8. So that's why we're using 8. So from 3 to 8 of v of t dt would equal P of 8 minus P of 3. So I don't have an equation here, but I have a graph, which means I have to go back and start finding area. So from 3 to 8. So this trapezoid right here and this triangle right here. So that's going to be 1/2 base 1, which is 3, plus base 2 times the height. And the height is 5 minus 1/2 2 by 2 equals P of 8 was 12 minus P of 3. Okay, so half of 4 is 2, so that's 10 minus 2. I'm going to go ahead and move that minus 12 over, equals a negative P of 3. So that's a negative 4 equals a negative P of 3. So P of 3 equals 4 feet. 4 feet. All right. Question B says, what's the acceleration when t equals 5? Okay, so a of 5 would be v prime of 5. Okay, so like a lot of times in math class, you do this one thing, you do this one thing, you do this one thing, and then you forget how to do other stuff because you've done this one thing so long. So we can't forget that acceleration is the derivative of velocity. Okay. So a of 5 would equal v prime of 5. So let's just say we need like just a slope, right? So that would be v prime of 5. It's linear. Thank you. So we could say 5 minus, I'm going from here to here. 5 minus 5 I did not do, I did 4/5. What happened to my eraser? So that's going to be 5 over -2, or negative 2.5 feet per square second. All right, question C. What is the net distance of the particle from 0 to 10? So net distance from 0 to 10 would be v of t dt. That's over here, right here, the net v of t dt is the net distance. So that's what we're doing right here. Okay. So the net distance that the particle travels would be 1/2. So all of this. So I'm going to do this trapezoid, this whole trapezoid, and then this whole triangle. So that's 1/2. It's 5 tall, and it's 6 and 2. And then this is below, so it's minus 1/2, 4 by 2. So that's 8. So that's 20 minus 4. So the net distance is 16 feet. Total distance. Okay, so total distance would be from 0 to 10, the absolute value of v of t dt. Okay, so that's going to be the same, except we're not going to subtract. I'm going to add that because everything has to be positive. So that's just going to be 20 plus 4, so that would be 24 feet. Now a table. Okay. Pens are getting in the way. All right. We have a table that shows the velocity in meters per second of a particle moving along the x-axis at selected values of time t seconds. What does the value of the definite integral from 0 to 18 of v of t dt represent? So if I'm going all the way from 0 to 18 v of t dt, go back to that first page. What does that represent? Well, it represents the net distance of the particle from 0 to 18 seconds. And if you look, all these values are greater than 0. So it's also the total distance. So it's the net distance and the total distance. So from 0 to 18, v of t dt represents the net distance particle travels from t equals, not 2, t equals 0, just turned into a 2. I have an eraser. From t equals 0 to t equals 18 seconds. And because all values v of t are greater than 0, then 0 to 18 v of t dt is also the total distance. That's probably hard to read, but I said it word for word, so pause it and write it. All right, using a left Riemann sum of 6 subintervals of equal length, estimate the value of 0 to 18 v of t dt, indicate units of measure. Okay, so from 0 to 18, v of t dt would be about, how many do we need? 6. Okay, so they're going to be 3 apart. Each one's going to be 3 apart. And it's going to be what's on the left. So that would be 3 times. So I'm going to use this one. That's my first one. And on the left, that's 2.3. Plus, then this one, and on the left is 2.7. Plus, here, and that's 2.0. Plus, the next one would be 1.3. Plus, the next one would be 1.0 plus 1.7. So that would be about, hold up, 33 meters. Okay, so then the next is a right Riemann sum. So 0 to 18 of V of t dt would equal, there's still going to be 3 in length, but this time I have to use the right side. So it's going to be, that's going to start at 2.7 and go from there. So 2.7 plus 2.0 plus 1.3 plus 1.0 plus 1.7 plus 2.1. So that would be 32.4 meters. And now a midpoint. So I'm going to erase this so we can kind of see what we're doing. All right. Three subintervals of equal length. So that's going to be 1, 2, and 3. So these subintervals are at a length of 6. And in the middle is, on that one is 2.7. In the middle of this one is 1.3. And in the middle of that one is 1.7. $34.2 meters. Oh my gosh, trapezoidal, come on. How many do you have to do? All right, so from 0 to 18, V of t dt, how many? 6 subintervals. So it's going to be 1/2 times the height. The height's going to be 3. And then you just have to add up the ends. So if I'm doing trapezoidal 6, so it's going to be like 2.3 and 2.7 are the ends. But then 2.7 is going to be the end of this one too. So that's going to be 2.3 plus 2 2.7s plus 2 2.0s plus 2 1.3s plus 2 1.0s plus 2 1.7s, but just 1 2.1 because it doesn't get put into that. It's not in that mix. Oh, that's, I just typed in 23 instead of 2.3. That's wrong. And I got 32.7 meters. All right, average acceleration for 3 to 9. Oh my gosh, were you able to see that? Sorry. Average acceleration for 3 to 9. would be v of 3 minus v of 9 over 3 minus 9. So v of 3 is 2.7. V of 9 is 1.3, and that's a negative 6. Negative 0.233 meters per second squared. That's what you got going on there. And then there's another part. For what value of t in the table is the average acceleration approximately equal to v prime of t? Explain your reasoning. Well, according to the mean value theorem, this acceleration should be approximately equal to v prime of 6. Because that's what's between, 3 and 9. Between 3 and 9 is 6. So this should be approximately equal to v prime of 6. So if you wanted to write that out, according to mean value theorem, you don't have to spell that out. You can use MVT on the test. This average should be approximately equal to v prime of 6. All right, so you've got a practice AP test question right here. I'm 90% sure you can find this one online. So I'm not going to work through this one right now. I want you to work through this on your own. And then if you can't find it online, we'll work through it. But you really need practice. We're not going to get the practice that you need. So let's just try and do as much as we can. So get any questions collected, and we'll talk about it later.